On the 26th of September 1940, 70 tons of high-explosive bombs reduced the Supermarine Production Center in Southampton to smoking rubble. German military radio quickly announced to the world that British fighter production was permanently crushed. At that critical turning point of the Battle of Britain, the Royal Air Force was losing up to 150 fighter aircraft every single week. The destruction of both the Woolston and Itchen facilities resulted in 110 casualties among specialized aviation personnel and completely flattened the primary assembly line of the Supermarine Spitfire Mk1. Military planners estimated that the island nation had fewer than 2 weeks of fighter reserves remaining before total aerial collapse. Yet, historical production records reveal an unprecedented operational turnaround. Instead of collapsing, frontline deliveries of the Supermarine Spitfire Mk2 doubled within 4 months. Lord Beaverbrook, heading the Ministry of Aircraft Production, executed an urgent strategic directive known as the dispersal scheme. The British leadership explicitly banned the rebuilding of centralized mega-factories, recognizing that large manufacturing hubs were fatal vulnerabilities against aerial reconnaissance. Overnight, the industrial footprint of the Spitfire was dissolved into hundreds of anonymous civilian locations across the countryside, creating a ghost production network that military intelligence could neither track nor bomb. Before we go on, what do you think is the most remarkable aspect of wartime industrial resilience? And tell me where you are watching from. Please subscribe to the channel so you do not miss our upcoming deep dives into strategic military history. Following the devastation at Southampton, Chief Engineer Joe Smith and his design group relocated immediately to the ballroom and cellars of Hursley Park near Winchester. Under extreme secrecy, this team re-engineered the complex assembly blueprints of the Supermarine Spitfire Mk2, breaking the entire airframe down into standardized modular sections. The legendary elliptical wing, engineered to withstand extreme high-speed aerodynamic loads up to 360 miles per hour, required over 1,000 countersunk flush rivets with tolerances under 0.5 millimeters. To manufacture these demanding aerospace components without dedicated industrial plants, the Ministry of Aircraft Production requisitioned 28 covert civilian sites across the rural city of Salisbury alone. Additional workshops were established inside Trowbridge, Reading, and Newbury. The Wilts and Dorset Motor Bus Garage became an essential wing assembly station because its high ceilings provided the 4.5-meter vertical clearance needed for heavy construction jigs. Nearby, commercial print shops, auto repair garages, local hotels, and agricultural barns were swiftly converted into sheet metal fabrication cells. The workforce powering this underground assembly network was comprised of more than 80% women, teenage apprentices, and elderly craftsmen who had never worked in aviation manufacturing. Following intensive 2-week training regimens, these civilian workers operated precision hand drills and pneumatic rivet guns with remarkable mechanical discipline. Strict compartmentalization governed the entire operation under the Official Secrets Act. Workers fabricating fuselage bulkheads in one garage had no knowledge of the wing panels being assembled 2 streets away. By dividing the industrial process across isolated civilian workshops, British planners eliminated any single point of failure, ensuring that tactical airstrikes could never halt the steady flow of fighter aircraft components. Once the modular components were completed across the distributed workshops, a covert transportation network went into operation under complete blackout conditions. Standard flatbed trucks were camouflaged under farm tarpaulins, canvas sheets, and loads of hay to haul fuselages and elliptical wings along rural country roads at night. These convoys delivered the prefabricated parts directly to dispersed grass flight testing grounds, primarily at High Post and Chatty's Hill. To evade aerial surveillance, military engineers avoided laying concrete runways, which easily reflected light on high-altitude reconnaissance cameras. Instead, the final integration of the Supermarine Spitfire Mk5 took place inside camouflaged canvas hangars and wooden barns directly adjacent to open turf fields. The assembly process at these forward points was streamlined so efficiently that arriving subassemblies were joined, fitted with Rolls-Royce Merlin engines, and wired for flight within 48 hours. Female and male transport pilots from the Air Transport Auxiliary arrived on site without prior combat briefing to conduct brief 30-minute functional flight checks over the countryside. Upon verifying flight stability and engine performance, these pilots immediately ferried the newly manufactured fighters directly to operational Royal Air Force squadrons across southern England. Throughout 1941 and 1942, aerial reconnaissance units of the Luftwaffe repeatedly photographed the abandoned, bomb-damaged craters at Southampton, mistakenly concluding that British single-seat fighter manufacturing was neutralized. In reality, the covert Salisbury network alone successfully produced more than 2,000 frontline Spitfires, without losing a single airframe to enemy bombardment. By masking the industrial footprint within everyday rural life, British defense logistics rendered high-altitude aerial bombing completely ineffective against tactical aircraft procurement. The uninterrupted flow of frontline aircraft delivered by this distributed manufacturing network kept the Royal Air Force combat readiness above 75% during the critical months of late 1940. This sustained defensive output directly forced the German High Command to indefinitely postpone Operation Sea Lion, the planned amphibious invasion of the British Isles. Over the course of the war, more than 22,000 Supermarine Spitfire aircraft of all variants were constructed, with nearly half of that total volume originating from dispersed civilian workshops and shadow facilities. This historic feat established a fundamental military principle, known today as distributed resilience. The core strategic lesson proved that a manufacturing complex without a centralized target cannot be eliminated through concentrated firepower. Modern defense planners across the globe now apply this very concept to contemporary theater logistics, developing agile combat deployment strategies to safeguard advanced airframes and tactical missile systems against long-range precision strikes and unmanned aerial swarms. The victory of the Supermarine Spitfire was not achieved solely in the skies above southern England, but within the covert garages, barns, and civil workshops where ordinary citizens transformed aerospace manufacturing under total secrecy. In modern warfare, where satellite reconnaissance can detect almost any physical installation on Earth, do you believe a distributed civilian manufacturing strategy could still protect aerospace production today? Or has precision surveillance made total industrial dispersal obsolete? Share your analysis in the comments below.